Okay, so I developed a small Excel solver model around multimodal transport and multimodal transport optimization. And you can see here there are 4 different transport modes that we can choose between, and the overall objective is to minimize shipping costs while maintaining customer satisfaction and satisfying customer demand. And in this video I wanted to go over the relevant cells here that are referenced by the underlying Excel solver model and explain basically the content of this file. So you can see here cells in various colors, and they all are linked with relevant input data or formulas, and I wanted to go about all of that to explain the content so that you understand what the meaning of it is. And if you want to access the Excel solver model itself and want to execute this model and adjust the values or maybe customize this file, then you can access it in the link of this video description and download it for a small fee in the Shopify blog and play around with the model yourself. So you can see there are various cells here. You can see we are talking here about 4 different transport modes: railroad, air, and sea. And so the problem is that we have these 4 transportation modes that we can use for distributing products that have been produced onto stock. So we're considering that we are a manufacturer that has to ship products from stock. We have 3 major customers, and we can ship our products via railroad, air, and sea. Each transportation mode, if used, will incur rental charges. These rental charges have to be paid regardless of the amount of products that are shipped through the respective transportation mode. And then there are also capacity limits associated with the transportation mode. We cannot go beyond these capacity limits. Then we also have to consider that only some of the customers cannot be reached by some of the transport modes. So, for example, some customers might not be possible to reach a given customer via, for example, sea. And now the problem is how to distribute how to satisfy all of the customer demand. This is a constraint. We have to satisfy every customer, but at the same time we want to minimize the transportation costs. And the transportation costs are the sum of the variable transportation costs per unit shipped via the respective transportation mode and the actual rental fees for renting and, so to say, activating the respective transportation mode. So if we go back here to the Excel file, we will start with the model parameters. So the model parameters are all of the input data that can be provided and changed by the user. So you can see here the transportation modes are listed, and you can see then here the relevant rental fees that have to be paid if the transport mode is activated. You can also see here the capacity limit, so the maximum amount of products that in sum, considering all of the customers, can be shipped through this transportation mode. Then we see here a connection matrix that defines which customers can be reached by which transportation modes. For example, customer A cannot be reached by sea, and customer C cannot be reached by rail. And lastly, we have a variable transportation cost matrix that contains the variable transportation cost per product shipped for the respective customer and transportation mode. So, for example, costs 2 cost units to ship 1 product via rail from the manufacturer to customer A. And the last set of input data that we can specify and change is the demand data. So those are the demands of the respective customers that have to be satisfied by the model. The gray cells, as always in my Excel solver models, those are the cells that can be adjusted by the solver. So Excel solver will try to change these values considering the input data in order to optimize the objective function. The objective function is here in the green cell, and in this case the objective function is, as you can see, the sum of the variable transportation costs and the rental costs for the activated transportation modes. So in the decision variables, we have binary decision variables here referring to whether a transportation mode is used or not. And then we have integer decision variables that contain the amount of product shipped via the respective transportation mode to the respective customer. And the objective function is simply the sum of the rental fees and the variable transportation costs. So Excel Solver will try to change the values here in order to minimize the shipping costs. And then lastly, what Excel Solver will consider are all of the constraints. So the constraints are listed down here. We have three sets of constraints. First, we have the demand satisfaction constraint, and then we have the rental capacity constraint and the connection constraints. The demand satisfaction constraints refer to the fact that customers have to be satisfied. Yeah, we have to make sure that the customers receive all the products that they demand. And so the blue cells always contain the constraint function. In this case, this is simply the sum of all the inbound shipping volume to the respective customer through all of the transportation modes. And then there are, on the other side, the constraint value, which is, so to say, the relevant constraint limit. You can see in this case the direction of the constraint is greater than or equal to. So the constraint function, the value of the constraint function has to be greater than or equal to the constraint value. And in this case, the constraint value is the demand of the respective customer, as you can see here. So Excel Solver will consider both the constraint values and the constraint functions and the directions of the constraints when trying to minimize the objective function. Here we have the capacity constraints. So these constraints are needed to make sure that we don't ship more products through a transportation mode than what is actually possible. And so here, to start with the direction of constraint, these are less than or equal to constraints. And the constraint function refers to the sum of all the material flow that is shipped via the respective transportation mode, as you can see here. And well, the constraint function value has to be less than or equal to the capacity limit. So the constraint value is the capacity limit of the respective transportation mode. So here I'm referencing the input data that defines the capacity of the respective transportation mode, and I multiply that with the binary decision variable of whether this transportation mode is used or not. So Excel Solver knows that the constraint value depends on the decision variable value, the binary decision variable of whether this transportation mode is used or not. The last set of constraint values that we have down here are the connection constraints. So what I have here are the theoretical upper limit of products that can be shipped through a respective transportation mode to a customer. So, for example, customer A, as per input data, we said that there is no C connection to customer A. And so what I'm simply calculating here for these constraint values is the multiplication of the input data, the binary input data that defines whether there's a connection or not, and the customer demand. And this gives me, for every customer in every transportation mode, from a connection point of view, theoretical upper bound for how much could be shipped through this connection. And this is either the demand value or it's zero. And then on top of that, in addition to that, Excel Solver will also consider the capacity constraints. So if, for example, for customer B, the C connection, theoretically there is a connection, so theoretically we could ship all of the demand, meaning 30,000 units, to this customer via C. But if C is already used, the C freight is already used for example, customer C, and there's no capacity left, then the actual volume shipped via C to this customer will be 0 or less than the demand. In this actual case, we have defined capacities here. C has a capacity of 60,000, and we can see here the optimal solution is to ship 30,000 units of product to customer B via C, and 30,000 units to customer C via C. And then customer C still has a demand of 10,000 units that are then shipped via road. Road has a capacity limit of 20,000, so the remaining 10,000 of capacity are in this case used to ship products to customer A. We can see air freight is not used at all, so it's in this case not financially optimal to use air freight. And we can see that rail is also being used. Rail has a capacity limit of 30,000, but it's only used to an extent of 10,000 units for shipping product to customer A. Customer A has a demand of 20,000, but 10,000 was already shipped via road, and so only the remaining 10,000 are shipped via rail. Referring also here down here to the constraint, you see the as per connection, the theoretical volume that could be shipped via road and rail is the total demand. But on top of that, we have the capacity constraints. So, for example, in terms of road, road had a constraint of 20,000. 10,000 was already used for customer C. So instead of 20,000, we are only using 10,000 because we also have the capacity constraints down here. Okay, if you download the Excel file from my blog and the link in the video description, as I said, I made it available on my blog and in the shop section of my blog for a small fee. Then you can see there also the instructions tab where I showed how to reference all of these cells in Excel Solver and how you can activate the Excel Solver add-in, and then you can execute the Excel Solver model that is already pre-set up there, and it will give you the optimal solution and the optimal result. The optimal result being the optimal shipping costs, and the optimal solution being the optimal material flow scenario and the optimal transport mode usage scenario.